if two or more simple sentences can be connected using a connective to get a compound proposition, and they are called as the connectives. This is very important concept. The negation of a proposition P is not P. So if you put not, the negation of a proposition P is not P, denoted as negation of P. False and false is false. In all other cases, it is true. So true and true is true. True and false is also true. False and true is also true. False and false is false. Right? Hello dear students, welcome to this session of basic mathematics class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session I am going to discuss regarding chapter 6, that is very important and simple chapter, that is mathematical logic. This is very important chapter and very easiest chapter. So the weightage for this chapter, from this chapter you will get 9 marks. So 9 marks is a weightage for this chapter, and very easily you can get 9 marks. So here in this chapter you will expect 2 1-mark question, 1 MCQ and 1 short answer question, and 2 marks 1 question. So 1 mark 1 question, that is 1 MCQ, 1 mark 1 question, 2 mark 1 question, and 1 5-marker question. So totally 5 plus 2, 7, 8, 9. So the total weightage for this chapter is 9 marks. So you will get 1 5 marks question from this, that is based on a construction of the truth table for the given proposition. And here simple problems you will expect for 2 marks 1 question, and 1 MCQ and 1 short answer question. So this is the weightage for this chapter. Now today in this session I am going to discuss regarding what is a proposition and how to construct the truth table for the given proposition or given proposition. Either it may be a simple proposition or a compound proposition. And the logically connectives. What are the logical connectives we are going to use to construct a truth table? So today let us discuss regarding what is the definition for a logic and what is a proposition, and how to write the truth table for the simple propositions using the connectives, that is logical connectives. Now let us know regarding what is meant by a logic. So this logic is nothing but logic is the subject which deals with the principle of reasoning. The subject which deals with the principle of reasoning is called a logic, or it is a mathematical process to arrive at the valid conclusion. So to arrive the validity or valid conclusion using certain valued assumption called the laws of logic. So it is the mathematical process to arrive at a valued conclusion using certain assumptions is called as a mathematical laws of logic. That is called as a laws of logic. So that means logic is a subject which deals with the principle of reasoning. And what are the laws of logic? Means it is a mathematical process to arrive at valid conclusion using certain assumptions, that is called as the laws of logic. Now let us know regarding what is a proposition and the truth values for a proposition. What is a proposition? An assertive sentence, any sentence, an assertive sentence or a statement which is either true or false but not both at the same time is called as a proposition. Any statement or any sentence, a sentence which is true or false is called as a proposition. Any statement, that is an assertive statement which is either true or false, is called as a proposition. For example, 5 is a prime number. Either it may be true or false, this is a statement. Similarly, root 2 is an irrational number. Either it may be true or false, whatever it may be, this is an example for a statement, that is called a proposition. A proposition is nothing but a statement which in the given context may be true or false. So 5 is a prime number, root 2 is an irrational number, is an example for a proposition. Now, sentences involving questions, exclamatory sentences, and expressions of opinion are not considered as the propositions. Any sentence, interrogative sentence, exclamatory sentences are not propositions. Say for example, weather is pleasant today. So whether this is true or false, we cannot judge. Therefore, this cannot be a proposition. Wish you good luck. This is also not a proposition. So sentential, what is your name? That is also, it's an interrogative sentence. So therefore, we cannot call it as a proposition. So any sentences, any statements, any sentences involving question marks, that is interrogative sentences, exclamatory sentences, expression of opinion are not considered as the proposition. So whether is here, whether is pleasant today is not a sentence. This is a sentence, but not, this is not a proposition. Wish you good luck. So this is also not a proposition. Oh, what a beautiful rose it is. Then it is not a proposition. So statement which involves exclamatory, interrogative and expression of opinion are not said, that is not considered as the propositions. Now, let us know regarding the truth values. What is the truth value? The truthfulness or falsity. The truthfulness or falsity of a proposition is called the truth values of the proposition. The truth values are denoted as T and F. So the truthfulness of true and falsity are T and F are called as the truth values. T and F are called as the truth values. So the truth values are T and F. That means the truthfulness or falsity of a proposition is called the truth value of a proposition, and it is denoted as T and F. The truth value of true is T and the truth value of falsity is F. Therefore, T and F are considered as the truth value. The truth value of a true proposition is denoted as T, and the truth value that of a false value of the proposition is denoted as F. T and F are called as the truth values. So they are called as the truth values of the given proposition, denoted as T and F. Now, logically connected. So what are logical connect? Any two simple sentences can be connected to get a compound statement by using the connective. A simple proposition is a statement which cannot be split into two or more statements. So a simple proposition is a statement which cannot be split into two or more statements. So if we split into two or more statements, then it is called as a compound proposition. So a simple proposition cannot be split into two or more statements. Let us consider, for example, set of natural number is finite is an example for a simple proposition. New Delhi is in India. This is also an example for a simple proposition. Root 2 is irrational. This is also an example for a simple proposition. So a simple proposition cannot be split into more than two or more than two sentences. These are example for simple propositions. Now, suppose if there are two simple propositions, the two simple propositions can be connected to get one more statement, that is called the compound proposition using the logical connectives. Now, a compound proposition made up of two or more simple propositions called a components, called its components. So, a compound proposition is made up of two or more simple propositions called its components. Now, let me explain the example. Let us consider an example for a compound proposition. Here, let us consider if x belongs to A, y belongs to B. Then x belongs to A union B is the compound proposition. Here x belongs to A, y belongs to B is the proposition, and x belongs to A union B is another simple proposition. Then they are combined together using if then to get a compound proposition. See, if x belongs to A, y belongs to B, then x belongs to A union B, if then to get a compound proposition. If then is called as the connective. Here if then is called as the connective. So if then, for this there is a special symbol that I will explain later on. So they are combined together using if then, that is called as a logical connective. So mathematics is easy or it is not raining today. Here these two statements are connected using a connective, that is or, right? So thus a simple sentences can be connected using the connectives to get a compound proposition. So a compound proposition is made up of two or more simple propositions. So mathematics is a simple proposition. It is not raining today. This is also a simple proposition. These two are connected using a connective to get a compound proposition. Here also X belongs to A, Y belongs to B is a simple proposition. Then X belongs to A union B is a simple. These two are connected by using a connective if, then that is called as a compound proposition. So that means if two or more simple sentences can be connected using a connective to get a compound proposition, and they are called as the connectives. Now let us move on to the first connective, conjunction. Very important concept. Conjunction denoted as P conjunction Q, reverse V, that is called as conjunction. The truth value for the compound proposition P and Q is true if both the components P and Q are true. If both P and Q are true, then only the statement is true. If both P and Q are true, then the conjunction is true. In all other cases, it is false. That means for a conjunction, if P and Q are any two statements, if P is true, Q is true, then P conjunction Q is also true. And in other cases, it is false. Suppose if P is false, Q is false, then P conjunction Q is also false. If P is true, Q is false, then it is also false. If P is false, Q is true, then also it is false. So the conjunction means and. Here if P and Q both are true, true and true is true. In all other cases it is false. Now let us consider a verbal example. So let us consider a statement. Let E is an vowel and Q is equal to 3 plus 4 is 7. E is a vowel and 3 plus 4 is equal to 7. So here let us consider the statement P as E is an vowel and Q is the statement 3 plus 4 is equal to 7. So this is denoted as P conjunction Q. P conjunction Q is E is an vowel and 3 plus 4 is equal to 7. If P is true, Q is true, then P conjunction Q is also true. E is an vowel, 3 plus 4 is equal to 7. This is true and this is also true. True and true is also equal to true. That means if P is true, Q is true, then P conjunction Q is also true. That means if E is an vowel and 3 plus 4 is equal to 7. So the entire statement is true. True and true is true. So how to write the truth table for this conjunction? So to write the truth table for conjunction, true and true is true. In all other cases, it is false. Now how to consider the elements? So P and Q. So let us write down the truth table. Very important. Constructing the truth table for the connectives is very important. Write down the truth table for conjunction. So P, Q, then P conjunction Q. P conjunction means P and Q. As I told now itself. So how to write the elements of P and Q? Here the elements of P are taken as first two true, true, then false, false, true, true, false, false, alternative true, false, true, false. So for conjunction, true and true is true. True and true is true. In all cases, true and false is false. False and true is false. False and false is also false. So that is how we are going to represent like this. So P, Q, conjunction. So truth table for conjunction. P conjunction Q, that is true, true, false, false, true, false, true, false. First true. P, first true or true. First two, true, true. Next true, false, false. Next for Q, alternative true, false, true, false. Conjunction, true and true is true. In other cases, it is false. True and false is false. False and true is also false. False and false is also false. So for conjunction, true and true is true. Remaining true and false is false. False and true is false. False and false is also false. This is how we are going to write the truth table for conjunction. Let us move on to the second one, disjunction. Disjunction is denoted as V. P disjunction Q. This is V. Reverse V is the conjunction, V is the disjunction. The compound proposition P disjunction Q is false when both the components are false. See, in the first case, both are true, then it is true. Here, if both are false, then it is false. In other cases, it is true. So, just the disjunction, P disjunction Q is false when both the components are false. In all other cases, it is true. So, true and true is true. True and false is also true. False and true is also true. False and false is false. F and F is F. Now let us take a verbal statement. Let us consider, let P root 2 is irrational and Q. What is Q? Q 9 is a prime number. So here P is true because root 2 is an irrational. P is true. Then what is Q? Q is false because 9 is a prime number is false, right? So the compound proposition P disjunction Q here is true. Hence it is true because true and false is also true. True and true is true. True and false is true. False and true is also true. Only false and false is false. So let us take an example. P is a true value here, that is root 2 is irrational. Q 9 is a prime number. So root 2 is irrational is a true statement. Q, that is 9 is a prime number, is a false statement. The compound proposition P disjunction Q, that is true disjunction false, is again true. That means if it is F and F, then only it is false, right? Now how to write the truth table for this? So false and false is false. In all other cases it is true. True and true is true. True and false is true. False and true is true. False and false is also false. So just as usual, write down P, Q and P disjunction Q, right? P disjunction Q. So what are the truth values we are going to write for this? So the truth values are like this. So true, true, false and false. True, true, false, false. For Q it is alternative true, false, true, false. Now what is the condition for disjunction? If F and F, then it is F. So false and false is false. In all other cases it is true. True and true is true. True and false is also true. False and true is also true. False and false is F. So this is how we are going to write the truth table for disjunction. So P disjunction Q. So true and true is true. True and false is true. False and true is also true. False and false is equal to false. Now next, negation. This is very important concept. The negation of a proposition P is not P. So if you put not, the negation of a proposition P is not P, denoted as negation of P. This is called the negation of P, not P. So let us consider, for example, calculus is difficult. What is the negation of calculus is difficult? Calculus is not difficult. Negation P, calculus is difficult. The negation of P is calculus is not difficult. Another example, let us consider Q. If root 2 is irrational, root 2 is irrational. What is the negation of this Q? Negation of Q is root 2 is not irrational. Root 2 is not irrational. So let us consider one more example. Root 2 is irrational. What is the negation of this? Negation of this is root 2, negation Q. Root 2 is not irrational. So how to write the truth table? The truth table for this negation is P, negation of P. If it is true, the negation is false. If it is false, the negation is true. For T, the negation is F. For F, the negation is T. Right. This is how we are going to write the truth table for a negation. For T, the negation is F. For F, the negation is true. Now let us know, by more knowing this, let us know the third one, fourth one, very important, conditional, that is called implication. Conditional statement implication. So if P and Q are any two simple proposition, then the compound statement or compound proposition, if P then Q, if P then Q, if P then Q is called the conditional of P and Q. So P conditional to Q is denoted as, this is how we are going to write P conditional to Q, or sometimes we may also represent P conditional to Q like this. Okay. So if P and Q are two simple propositions, then the compound statement if P then Q is called as the conditional statement, and it is denoted as P conditional to Q. Now what is the truth value for this? P conditional to Q is false if the antecedent, that is P, is true and the consequent Q is false. If P is true and Q is false, then T conditional to F is false. In all other cases, it is true. So, P conditional to Q is false. This is false if and only if P is true and Q is false. True conditional to F, then this is false. In all other cases, it is true. So, P conditional to Q is false if the antecedent P is true and the consequent Q is false, false proposition, then it is false. In all other cases, it will be true. So, for conditional proposition, for P conditional to Q, true and true is true, true and false is false. Again, false and true is true, false and false is also true. So let us write down the truth table. So what is the truth table? Same. P conditional to Q. This is the conditional statement. If P, then Q. True and true is true. True and false is false. False and true is true. False and false is also true. Only this is false. So true and false is false. In all other cases, it is true. So how to write the truth table for conditional? This is P conditional to Q. P conditional to Q. So here, as usual, write true, true, false, false, true, false, true, false. So true and false is false. True and false is false. In all other cases, it is true. So true and true is true. True and false is false. False and true is true. False and false is also true. This is the truth table for conditional. Right. Now move on to the next one. That is the biconditional. Biconditional, or it is also called as the double implication. First one is a single implication. Here it is double implication. That means if P and Q are two simple propositions, then the compound proposition P if and only if Q. P if and only if Q. P if and only if Q, denoted as P biconditional double implication, is called as the bicondition, or it is called the double implication. So P biconditional to Q, or sometimes it may also denoted by double implication like this. That is, what is this? If and only if. If and only if. So if and only if, that means P and Q are two simple propositions, then the compound proposition denoted as P biconditional to Q is called the biconditional or double implication. That is P if and only if Q. Now what are the truth values? So here, if both the statements, if P is true, Q is true, then the biconditional is also true. If P is false, Q is false, then biconditional is also true. In other cases, it is false. True and false is false. False and true is also false. True and true is true. False and false is also true. So here in this biconditional, so true and true is true. Similarly, false and false is also true. In other cases, true and false, false and true, they are equal to false. If both the statements are true and true, it is true. If both the statements are false, false and false, then also it is true. In other two cases, true and false, false and true is false. That is the double implication biconditional. Now, how to write the truth table for the biconditional? The biconditional P biconditional to Q is true when the components P and Q are having the same truth values, like true and true, F and F. In other cases, it is false. So P biconditional to Q, this is biconditional if and only if, right? So that is P biconditional to P. True and true is true. False and false is also true. In other two cases, true and false is false. False and true is also false. So true and true is true. True and false is false. False and true is false. False and false is also true. This is how we are going to write the truth table for a biconditional statement. Now, so far we have discussed regarding the truth table for conjunction, disjunction, conditional, biconditional and negation. Now, let us write all the truth values in a single table. Let us represent the truth values for all the logical connectives using the single table. That is, truth values for all the logical connective may be written as like this. So, here what are the connectives? Conjunction, disjunction, conditional, biconditional and negation. So, these are called as the connective. This is conjunction, disjunction, this is negation, conditional and biconditional. So, that is P conjunction Q, P disjunction Q, negation P, then conditional to P, P conditional to Q and P biconditional to Q. Now let us write down the truth values for all the connectives. That is P, Q, P conjunction Q, conjunction, P disjunction Q, negation of P, P conditional to Q and P biconditional to Q. As you know, the truth values for P is true, true, false, false. For Q it is true, false, true, false. T, T, F, F, T, F, T, F. For conjunction, conjunction means true and true is true. In all other cases, it is false. So, true and true is true. In all other cases, it is false. True and true is true. True and false is false. False and true is false. False and false is also false. Now, whereas in disjunction, false and false is false. So, false and false is false. In all other cases, it is true. So, true and true is true. True and false is also true. False and true is also true. False and false is false, right? So, in case of conjunction, true and true is true, remaining are all false. Whereas in case of disjunction, false and false is false, in all cases it is true. So, here 1F, 3T, here 1T, 3F. Now, in case of negation, negation is opposite. For negation of P, true it is false, for true it is false, for false it is true, for false it is true. Negation of T is F, F is T. Now, conditional statement. Conditional means what? True and false is false. True and false is false. In all other cases, it is true. True and false. If the first statement is true and the second statement is false, then it is false. In all other cases, it is true. So, true and true is true. True and true is true. True and false is false. False and true is also true. False and false is equal to true. So, in case of conditional, true and false is false. In all other cases, it is true. True and true is true. True and false is false. False and true is also true. False and false is also true. Whereas biconditional, in biconditional statement, if both the statements are having the same truth values, true and true or false and false, T and T is T and F is also T. True and true is true. False and false is also true. In other cases, true and false is false. False and true is also true. So, in case of biconditional, true and true is true. True and false is false. False and true is false. False and false is equal to true. So, this is how we are going to write the truth table for all the connectives: conjunction, disjunction, conditional, biconditional and the negation. Very simple concept. Conjunction, for conjunction, true and true is true. In all other cases, it is false. For disjunction, false and false is false. In all other cases, it is true. For negation, true is false, false is true. Whereas for conditional statement, true and false is false. True and false is false. In other cases, it is true. For biconditional statement, if both statements are same, that is true and true is true, false and false is also true. In other cases, true and false is false, false and true is also false. So, this is how we are going to write the truth table. So, if you know how to fill this, how to write the truth values for P and Q, true, true, false, false, true, false, true, false. Then conjunction, true and true is true. Disjunction, false and false is false. Negation, for negation, true it is F, for F it is 3F, for F it is T, for F it is 3. For conditional, true and false is false. And for biconditional, true and true is true, false and false is also true, and remaining cases it is false. This is how we are going to remember the truth table for all the logical connectives: conjunction, disjunction, conditional, biconditional and the negation. So, this is very important. Once if you know this table, you can solve any problems in 5 marks, right? So, that's all regarding today's session. Let us meet with the different types of problems in the next session. Thank you very much.